Hello friends, welcome to today's session. In this video, we will discuss one of the most important concepts in power system protection, zones of protection along with primary and backup protection. Power system consists of generators, transformers, busbar, transmission and distribution lines, etc. There is a separate protective scheme for each element of power system, like generator protection, transformer protection, transmission line protection, etc. That means we can say that power system is divided into number of zones for protection. The protective zones are planned in such a way that the entire power system is covered by the protective devices like fuse or circuit breakers. And therefore, no part of the power system remains unprotected. The adjacent protective zones must be overlapped with each other. Without overlapping, a fault occurring at the exact point where two protection zones meet could be missed by both protective relays, which can create a dead spot where no protection is activated. Here, for example, you can see that HV switchgear protection is overlapped with generator protection and transformer protection. Same way, transformer protection is overlapped with HV switchgear protection and EHV switchgear protection. And EHV switchgear protection overlapped with transformer protection and transmission line protection. Overlapping ensures that every single component of the power system is included in at least one protection zone, and critical equipment is covered by two or more zones. The overlap creates a built-in backup for the primary protection. If the relay in one zone fails to operate during a fault, the relay in the adjacent overlapping zone can still detect the fault and trip the circuit breaker. Now we discuss about primary and backup protection. If a fault occurs in a particular zone, it is the duty of the primary relays of that zone to isolate the faulty element. Thus, the primary relay is first line of defense. If due to any reason the primary fails to operate, there is a backup protective scheme to clear the fault as a second line of defense. The causes of failure of primary protection schemes may be due to failure of DC supply to the tripping circuit, or failure of circuit breaker tripping mechanism, failure in the wiring of the relaying mechanism, or it may be due to failure of CT's or PT's operation. Therefore, backup protection is very important for stable and reliable power system, because we know it is not possible to design a 100% secure and efficient system. Moreover, when we disconnect primary protection for testing or maintenance purpose, then secondary or backup protection can act as primary protection. There are basically two types of backup protection: remote backup and local backup. Remote backup protection provides backup relays in a separate or neighboring station. This provides an independent layer of protection because the backup protection is not affected by the same factor that might cause the primary protection to fail. Remote backup systems often use telecommunication channels to communicate with the primary protection devices and respond to fault signals. If the primary protection fails to clear a fault, the remote backup will receive the signal and initiate a trip to clear the faulty section. This is the simplest and cheapest form of backup protection and widely used for transmission lines. Local backup protection provides backup relays in the same station. It is subdivided into two types: relay backup and breaker backup. In relay backup protection, an additional relay is provided for backup protection. It trips the same circuit breaker if primary relay fails to operate. Suppose, for example, a transmission line is divided into number of sections, and for each section, circuit breaker and relays are provided for protection. Now suppose a fault occurs beyond section D. Due to fault, the relay and circuit breaker which is installed in section D should operate as first line of defense. Now suppose the relay R4 installed in section D fails to operate. Therefore, the relay R3 which is installed in section C will operate as second line of defense. And it will trip the circuit breaker to isolate the faulty element. In breaker backup protection, an additional circuit breaker is provided for backup. When a protective relay operates in response to a fault, but the circuit breaker fails to trip, then backup circuit breaker will operate. For example, if the fault occurs beyond section D, then relay R4 will operate to send trip signal to the circuit breaker, which is installed in section D. If this circuit breaker fails to operate, then R4 relay close the contact of R3 relay which is installed in section C, and the circuit breaker from section C will trip to isolate the faulty element. So friends, that was all about the zones of protection, primary and backup protection. If you found this video useful, kindly like the video, share it with your friends and post your comments below in the comment box. Subscribe to the channel and press the bell icon to receive notifications for upcoming videos. Thank you.